Welcome to my channel. I'm so glad that you could join me. My name's Jody, and over here it's just you, me, and math. And in this particular video, we will be talking more about the quadratic formula. So my last video is when I introduced it, I did a bunch of examples and so on. But in this video, I'm actually going to show you what happens when you get an imaginary solution and also talk about the discriminant. So if that sounds interesting, then let's get right into it. As a recap, the quadratic formula here, which is normally written with negative here, but as I explained in my last video, I just like to have it say opposite, and you just take the opposite sign. This formula is used to solve equations of this form, ax squared plus bx plus c. Make sure that it does equal 0. So in this example I'm going to do here, it doesn't equal 0. So we need to make it equal 0 by moving the 4 over. So let's add 4 to both sides, and then it will equal 0, and we can work with our formula. X squared plus 2x plus 7 equals 0. Now that it equals 0, let's identify a, b, and c and plug them into our formula here. So a is going to equal 1, b is 2, and c is 7. All right, so let me write this out and we will get going on the details here. So I like to simplify underneath the root first. So let's do that. This would be 4 minus, and put all these together, so it's going to be 4 minus 28. So that is going to leave us with x equals negative 2 plus or minus the square root of negative 24 all over 2. Now, if you were to type the square root of negative 24 into a calculator, you'll get something that says error or syntax or domain error, something like that, because you can't square root a negative. So what I'm going to do is break down the 24 as if it were a root positive 24, and then I'll tell you how to deal with the negative. Just going through this quickly because I've gone over it in previous videos. However, remember that the pairs of numbers get to leave the root, and the ones that don't pair up, they don't leave. So how this is going to work is we're going to write it as negative 2 plus or minus 2 root 6. Notice I left a little bit of a blank there, and that is because anytime you square root a negative number, it actually comes out to be an imaginary number. So what you want to do is have an I in there to make sure that you knew that it was negative. Now, that can be a whole separate video on how that works, but as a very quick explanation, you can rewrite root negative 24 as root negative 1 times root 24. This is what I is defined to be. So square root of negative 1 is I, and the 2 root 6 is the root 24. So then all of that is over 2. Now, there are a couple ways to simplify this, but I'm just going to do it the quicker way that I showed you in my last video. And that is to divide all of the whole numbers by the exact same thing. So I'm going to divide them all by 2, reduce it down, and then we'll have our answer. So if we divide by 2, divide by 2, and divide by 2, our final solutions will be negative 1 plus or minus I root 6. Now, I'll tell you what that means on the next part when I talk about the discriminant. However, again, just as a brief overall recap, square root the number, simplify it as far as you can, and just put an I with it to signify, hey, I was rooting a negative, and that's not something that you can do. So let's move on to the discriminant, and you'll see how that works, but I hope that this makes sense. All right, the discriminant of a quadratic equation is just the b squared minus 4ac part, not the root part, nothing else. Now, you might wonder, why would I need to know just that part? Why not do the whole entire formula? Well, many reasons. It can be a quick way to know how many solutions there are to an equation, but also all sorts of placement tests such as ACT, SAT, ALEX, all sorts of placement tests really like to talk about the discriminant and the quadratic formula and how to know what types of solutions they produce. So very important to know. So I've kind of drawn up a couple things here. Now, when the discriminant, which is b squared minus 4ac, comes out to be a positive number, that means you have 2 real roots. Roots are another word for x-intercepts or zeros or solutions. I know, lots of vocab. So it would look something like this. Root positive any number, you'll be able to split that up into 2 positive numbers. And what that gives you are these 2 places right here where your parabola will cross your x-axis. So 2 real roots means it'll cross in 2 places. Now, if your discriminant is 0, then it would look something like this, and root 0 is 0, so it would go away. So all you have left is opposite b over 2a. That is one solution. It means your parabola touches the x-axis only in one place, which is also its vertex. And you might remember the formula to find a vertex is negative b over 2a. Now, when you get a negative number underneath, any negative number, that means your parabola is not going to cross your x-axis at all. They don't have to cross. A lot of times they do, but they don't have to. So if you get a negative number underneath the root, if you get a negative discriminant, you're going to have no real solutions at all. You're going to have two imaginary solutions. So those are going to be solutions, but it just means that your parabola will not cross your x-axis. So let's do a bunch of examples so that you can see how this can be really, really useful, and we'll go from there. In these three examples, if you want to pause the video and try them yourself, that would be fantastic, but I'll work them out with you as well. So all we're going to do is find the discriminant. We're not going to do the whole quadratic formula, just the discriminant. So let's find b squared minus 4ac on each one and then state how many solutions that means that our equation will have. So let's go about doing that. So this is going to be b squared, 5 squared, minus 4 times a, which is 1, and c, which is 4. So what we get here is 25 minus 16, so the value of the discriminant is 9. Simply because that's a positive number, we already know there are two real solutions, so your parabola would cross the x-axis twice. Let's do the same thing here, b squared. If b is negative, especially when b is negative, put it in parentheses so that when you square it, you come out with a positive. This first number, b squared, should always be positive. b squared minus 4 times 2 times 4. That's going to be 1 minus 32. So that gives us negative 31. So that's kind of gross. We can't square negative 31. So that means there would be two imaginary solutions and your parabola would never cross your x-axis. So how about our last one? 6 squared minus 4 times 9 times 1. 36 minus 36 is 0. So anytime we get 0, that would be one real solution. So let me kind of summarize over here, and I'll come right back in just a second. Here we go. So I put my words on paper, and by paper I mean my whiteboard. Now, why would the discriminant be useful? A, because it's on all sorts of placement exams and exams you're going to encounter, and B, because let's say you're supposed to graph a parabola, and so you want to know how many times it crosses your x-axis. Well, if you were trying to do number 2, for example, and you just did the discriminant, you'd be like, oh, well, that's never going to cross the x-axis, so there's no point in doing the whole quadratic formula, so it just saves you some time, right? Yeah. Whereas these ones, you're going to know, hey, okay, positive number, it is going to cross 2 times. So if you just did the full quadratic formula, you already know what's under the root, solve her out, and get your two real solutions there. Now on this one, what's kind of cool about when the discriminant is 0 is that it only touches the x-axis once, which also has to be your vertex. So if you're trying to graph it, you have your vertex, you are good to go. So the discriminant, very, very useful in a lot of situations, so I hope that it makes sense. So with all that being said, let me know if you have any questions about anything that I've done with the discriminant down in the comments. All right, my friends, I hope that that was helpful. I tried to keep this one a little bit shorter. I know I tend to want to go very, very thoroughly into topics, and so I end up talking too much, as I am right now. It is what it is, but I appreciate you being here. I hope you learned some things, and I hope that you'll subscribe to my channel and come back next time for more videos. Please also let me know what topics you'd like me to cover down in the comments, and I hope to see you next time. Have a beautiful, beautiful day wherever you are. Bye, guys.